Hello dear students, we are going to deal with electric charges and fields, the first chapter into your first part of your physics textbook. Now electric charges and fields are going to be two different concepts. We are going to first find out about electric charges and then we are going to discuss about electric fields. Electrostatics is a branch of physics which deals with electric charges at rest. Hence, this word is being taken as a combination of electric charges at static or static electric charges, which can be even further said as electric charges at rest or static electric charges. Now, in this branch of physics of electrostatics, we would be discussing electric forces between static charges and then electric field due to these charges, and finally electric potential due to these charges. Well, into this chapter we are keeping our discussions limited only up to forces and electric fields. About electric potential we would be discussing it into the next chapter. Well, in this slide we see that a girl placing her hand on a charged metal plate has her hair strands moving in all other directions. All of you must be wondering what phenomenon actually causes this. Some of the students must have experienced this while doing so. So when this girl is placing a hand on this metal conductor, which is supposed to be a charged metal conductor, her hair strands move in all directions. Similarly, you all must have noticed the lightning in the sky during thunderstorms. Both these slides have a common answer that we are going to deal into this chapter, and that never takes place very commonly. But now if you see all the previous slides, that is the hair of the girl moving in all directions when hand was placed on a metal conductor, the lightning that takes place in the sky, as well as a plastic material when rubbed on dry hair attracts small bits of paper. All of them have a common answer, that is due to electrostatics. Charges get transferred when one body is rubbed against another. So when the girl placed her hand on the metal conductor, there were charges that got transferred from the metal conductor to the girl's body. Similarly, when there is lightning in the sky, there is discharge of charges from one cloud to another. The reason is when a cloud which is heavily charged comes closer to another cloud, there is exchange of charges due to which we see the phenomenon of lightning that takes place. And similarly, when you rub a plastic material on dry hair, some of the charges are transferred from the plastic scale to the hair, because of which that plastic scale now tries to attract some other lighter objects towards it. Well, this process of bodies attracting lighter objects after being rubbed on different objects or bodies was first noticed by Thales from Miletus, a place in Greece. It was seen that amber, when rubbed with wool or silk, attracted lighter objects such as bits of straw or bits of paper. And this was noticed somewhere around 600 BC. Here you all can see a person holding a bit of amber which has been rubbed with wool or silk, and then after that started attracting smaller bits of paper. This was first noticed by Thales. As shown amber over here, it is usually a material that grows on the bark of trees, where in this part of the country or this part of the region we consider it to be a piece of gum or something that comes out from trees. I'm sure all the students must have seen it somewhere or the other. And this name electricity came from Greek word known as electron, where electron in Greek actually means amber. So this whole thing is being summed up into this whole slide where you can see from here. Well, there are three simple experiments to verify the existence of electric charge on bodies. First, let us consider a glass rod which is freely suspended by a silk thread. And now this glass rod is being rubbed with the help of wool. And if I take another glass rod and rub it with wool and now place it very close to the suspended glass rod, we see that both the glass rods start repelling each other. Similarly, if you repeat the same experiment with a plastic rod, where one of the plastic rod which is rubbed with cat fur is being suspended freely with the help of a silk thread, and then another plastic rod which is rubbed with cat fur is placed very close to the suspended plastic rod, both of them start repelling each other. So in both the cases it is seen they repelled each other when they were rubbed with wool and cat fur respectively. Now if we consider the suspended glass rod which is rubbed with wool and you place a plastic rod which is rubbed with cat fur very close to each other, both of them started attracting each other, hence showing that glass rod and plastic rod were oppositely charged. It means that charges do exist on bodies when you rub it with wool or cat fur or similar other materials. From the above experiments, it was quite clear that when glass rods were rubbed with wool and placed very close to each other, they repelled each other, indicating that both the glass rods acquired a similar charge on them. And when both the plastic rods were placed very close to each other, after being rubbed with cat fur, also repelled each other, indicating both the plastic rods also acquired a similar type of charge. Now, when this suspended glass rod was placed very close to a plastic rod where both of them had been rubbed with wool and cat fur respectively, attracted each other, showing that the charges acquired by glass rod as well as the charges acquired by the plastic rod were completely opposite to each other. Hence, they were attracting each other. Coming from the previous experiments, we now define what is electric charge. So electric charge is defined as the property possessed by material objects or particles which makes it possible for them to exert electrical force and to respond to electrical force. Hence, from the previous experiments, we get some results where we can now conclude saying that some bodies on rubbing acquire charges. That is, whenever you rub a body, that body gains some charges. Bodies with like charges will always repel each other, and bodies with unlike charges will always attract each other. Charges can be transferred from one body to another body. Conventionally, charges acquired on the glass rod were called positive, and the charges acquired on the plastic rod were called negative. It was Benjamin Franklin who named the charges as positive and negative. So you can even say it was Benjamin Franklin who gave polarity of charges. And last, if an object possesses an electric charge, it is said to be electrified or charged. When it has no charge, it is said to be neutral.